Okay, Aubrey, and I think that's it. Everybody's here today, right? Okay. 5-1, we are starting chapter 5. We're skipping over chapter 4, and this is angles of triangles, okay? I'm going to go through the homework assignment so that she can write that down, and anybody who else has not yet. 1 through 17 all. Buh. It's fine. And number 22, okay? So those guys. It's still only one page, I think, right?
I don't know.
Is it? I think it's only one page. No, well, like one paper, though. You can throw the other one away, right? Okay. All right. Okay, I try to do that as often as possible. Sometimes it's not possible. All right. Angles of triangles. This is the most important piece of information. If you don't listen to anything else I have to say today, here's what it is. Ready? In the next 5 seconds, this is the most important piece of information. Here is a triangle, and all of these angles have to add up to how much? 180. There you go. That's all you, well, not all you need to know, but there's the most important piece of information. So, if they give you 2 of the angles, you can find out the third one, right? Now, I shouldn't have put these little loop-de-doos here, right? Sometimes they will do this to you and they will give you a triangle and they'll say, like, this is 100 degrees, right? Okay? But then they will do this. Typically, these little loop-de-doos mean that those two are the same. So even though there's 2 missing ones, I know that they are equal to each other. How do you do this? Yeah, like 180 minus 100 that's already there, right? Is 80, and I divide that in 2, so each one is 40, right? Like, this is mental math, some of it, right? Okay? Then we'll get into a little bit of algebra stuff, but basically, in a nutshell, that's what we have, right? Interior angles of a triangle, they all have to add up to be 180. That's what this theorem says, right? 180 is the sum. Okay, now we will get to, like, this guy. What is the measure of each numbered angle? Okay, how many angles are numbered that we need to find? 3. We have angle 1 equals angle 2 equals angle 3 equals. I will tell you, you do not necessarily always solve them in that order, right? If it were me, I would solve probably angle 2 first, although you could solve angle 1 first, right? Angle 2 is this guy right here. 57 plus 71. Can you do that in your head?
No.
Yeah? 128. Okay. If you subtract that from 180, it is like 52. Yeah? I think I heard Jack say 52 degrees is what angle 2 is. Got it. Done. Okay, now I could have solved angle 1 first. How do I find angle 1?
Well, 57.
Okay, this right here is a straight line. Yeah? Okay, a straight line makes 180. So that means this angle here and this angle here have to add up to be 180 because it's a straight line, right? If this is 57 already, then this one has to be 123. So angle 1 is 123. All right, now I have to use that information to solve angle 3, right? So if this is 123 here, I can add these two together, right? 123 and 28 is like 151. And if I subtract that from 180, is 29 degrees. That's what angle 3 is. There you go. Okay, not too bad. Was that okay? Yeah? Okay, so just keep those little tidbits in mind. If it's on a straight line, those will add up to be 180. All the things. If it's a triangle, those add up to be 180 as well. Got it?
Will we always be given 2 triangles?
Sometimes you're only given 1 triangle.
I don't know.
Yeah. It just depends. I don't know. We'll see. Like let's say this guy. Okay? This was the check on the next page. Okay, but I want to talk about him. Angle 1, if I add 43 and 74 together, that is 117. Is that true? If I subtract that from 180, that is 63 degrees, right? So angle 1 is 63 degrees. How do I find what angle 2 is?
They're vertical angles.
They are vertical angles. They're across from each other. So this is also 63 degrees. Yeah? Then 63 and 79 is like 142. Is that true? And then if you subtract that from 180, what's angle 3 going to be? 38 degrees. Okay? These are not hard, right? Like these are pretty quick. Now, I will caution you because guess what? If I do my math wrong and this number is wrong, this number is wrong and this number is wrong. So just take caution and go slowly. But
2 wrongs can make a right.
sometimes they actually do. Okay. All right, next thing. This is another important thing that you don't already know, so here you go. Listen to this, okay? We have a triangle, and then they have this line that's like jetting off from the triangle, right? It's making angle 4 and angle 2 for one thing. Angle 4 and angle 2 have to add up to be 180 because this is a straight line. But We have interior angles of a triangle, and then we have an exterior angle, right? There are 3 interior angles. Because we only have one side that's jetting off, I only have one exterior angle, right? Okay? I could have multiple exterior angles. Like I could make an exterior angle here, or I could make an exterior angle here, or I could go the other direction and make an exterior angle here, right? Okay? But for this purpose, they only have one exterior angle. Got it? Okay, let's see what we've got going on here. Let's do this. Okay, you ready for this? This is a little shortcut, okay? Some of this stuff, I'm going to talk about the ACT for like 2.5 seconds here, okay? So some of the stuff that's on the ACT, some of the stuff that's on the ACT is like you can figure it out, right? Like it's not terribly difficult, but one of the huge parts of the ACT is like you run out of time, right? Like you do all the problems all the way through and then you run out of time and you end up bubbling like the last 10 questions, right? Okay. There are little hints and little like shortcuts built in math throughout so that you can get to answers faster, therefore having more time for questions at the end, right? And it's just like handier because you get done with your homework faster, right? This is one of those times, okay? Are you ready for this? This is called the exterior angle theorem, and they talk about it right here, but they're going to run you through the proof. I'm just going to tell you what it is. Are you ready? Here you go. Angle 1. I'm going to put a theoretical angle 1. How big does angle 1 look-ish? That's not 200 degrees.
30.
He looks like he's 30 degrees. Like 90 degrees would be that much. I'm going to say 50, actually. Let's go easy. We'll go easy like by tens numbers, right? Let's say that angle 1 is 50 degrees. Sure. I'm just hypothetically putting that in there. Ready? Okay. Angle 3, let's make him, just so that they don't end up being the same, let's make him 60 degrees. I don't know.
And 70.
Actually, let's make him 30 degrees. Angle 3 is 30 degrees. I have a method for my madness here. Okay, so 50 degrees, 30 degrees. Ready? They want to know what the measure of angle 4 is.
80.
And you can find it easily, right? So here's what I'm going to do. If I'm trying to find angle 4, we've got to add these two together, and that makes 80, right? Okay, so that's not too bad. That's 80. So what's the measure of angle 2? 100, right? Then I know that 2 and 4 have to add up together to be 180, so angle 4 is 80. Here is a rule. Are you ready? The exterior angle in this case is angle 4. Got it? Okay? The two angles that angle 4 does not touch are angle 1 and angle 3, right? This guy will always be these two added together. Does that make sense? Okay? So let me show you here. Let's say I have this triangle here and I have this guy, and this is angle 1, angle 2, angle 3, angle 4, right? If I want to find angle 4, he will be the same as which two added together? 1 and 2, always, because you have to add these together to make that, subtract from 180, and then subtract from 180 again. The exterior angle is always the measure of these two ones that he does not touch added together. Now, great, you can get to that eventually. Angle 4 you can solve for eventually if you solve for angle 3 first, blah, 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 all the things, right? But if you know that to begin with, if you know that shortcut, you can get to that in one step rather than two. And that saves a ton of time, especially when you're looking at ACT stuff. So remember that little tidbit. That's something called the exterior angle theorem. It's just the way the angles fit together. That's how it works. Got it? The two angles he doesn't touch added together make up that exterior one. Got it? Woo! Okay, let's go to example 2. You see this little house guy? Now we get to the algebra stuff, okay? I'm going to draw a picture of this better over here so that you can see him. Okay, we've got this, and we've got this little house guy, and there's that. Okay, this angle down here in this corner is 65 degrees. Do you see that? Yeah, like this guy? This is C. Okay, this little guy right here is 6x minus 4. Yeah? Okay. And what's the 12x plus 7 like referring to? The exterior angle, this guy right here, is 12x plus 7. Oh, gosh. Now I don't even know what the stuff is.
You set them equal to each other.
Yeah, like we know the exterior angle, the ones that he does not touch are these guys and this guy, right? So if I add these two together, it's equal to this guy, okay? If I add those two together, so I've got 6x minus 4. If I add that to 65, that is equal to 12x plus 7, yeah? And now I do the math. Okay, do you see what I just did? These two smaller ones, these two interior ones added together, not including the one that he touches, right, is added together is equal to that outside one. Got it? Okay, let's do the math. What should we do first?
Add 65 and negative 4.
65 and negative 4 makes 61, yeah? And then what?
Subtract 7.
Minus the 7 over, so that makes, I don't know, 54, yeah? I'm going to then subtract the 6 over as well. Can I do that in the same step? Yeah? So 6x here equals 54. X is 9 if you divide by 6, right? X is 9, but always check. Find the measure of DAB. Which one is DAB?
The exterior.
DAB, the exterior one. So I want to plug 9 back in for X there. And 9 times 12 is at 108. Plus 7 is 115. I think I heard Sienna say. Yeah, perfect. Okay, so don't just stop in the middle. Make sure you look back. After you solve for X, it's like notorious for geometry, always wanting to know one more step than what the X is, right? Okay, let's see. Oh, yeah. Okay, here's another shortcut. Are you ready? Another shortcut. Okay, let's make this shorter, right? Okay. All right, this is a right triangle. Yes? That means it has one right angle. Okay. Let's say I know that this is 25 degrees. Okay? There's a short way and a long way to do this. You want to do the short way. Yes, I know that they all add up to be 180, right? So I could take 90 plus 25 and then subtract from 180, right? But if this guy is 90, these two add up to be the other 90, right, to make 180. So rather than adding these two together and subtracting from 180, let's just take 90 minus 25 to find the other one. Can we do that? It's 65 degrees. That's another shortcut, okay? So, yes, you'll get to the correct answer if you add them together and subtract from 180. But if this is 90, these other two are also 90. That's what it says right here when it says the acute angles, acute meaning this one and this one, of a right triangle are complementary. What's complementary mean? Equal 90. They add up to be 90. So the two smaller ones add up to be 90 if the third one's 90, right? Okay. So don't add them together and subtract from 180. Just subtract those two from 90 or like figure out the other one, right? Okay. And then this one says, this is another like theorem. It's called corollary. It says there can be at most one right or obtuse angle in a triangle. Can you have a triangle that has two right angles? Like I can try to make one, right? There's one right angle, right? But then if I try to make another right angle, does that make a triangle? No. It won't touch at the top, right? Okay? Or let's make an obtuse angle. There's an obtuse angle, right? If I try to make another obtuse angle, it won't touch at the top, right? It like I could close it off and it make like a trapezoid or whatever, but that's not a triangle, right? So I can have what?
If it's on a sphere.
If it's on a sphere, yeah, but then it's not a triangle. Oh, I get you. Yes. I get you. Okay, that was like something in college. No, that's something in college that like completely blew my mind. Okay, like I understand what he's saying like full force here. Okay, this like blew my mind. This is something called spherical geometry. There's a whole class on it. Look it up. Okay, so just in case you're wondering. Okay, so here's a sphere, right? Okay, tune me out if you don't want to listen to this, and then I'll tell you when to tune back in. Ready? Okay, so here's the top. Here's the North Pole, right? If I go straight down, right? And then I go straight over, right? This is a 90-degree angle, but it like curves around, right? And then let's say I go straight down from there. This is a 90-degree angle, and this is a 90-degree angle as well. Did you know that? Like it's like an eighth of a sphere. You know what I'm talking about? That's something called spherical geometry. And those do not add up to 180. It's the weirdest thing ever. Like there's ways of like calculating angles and stuff. And it also like spherical geometry takes into consideration the curvature of the earth. So when you're talking about distances between like Blue Hill and Hastings are not a large enough distance to have to take into consideration the curvature of the earth. But if you're taking into consideration like the distance from here to like Egypt, you have to look at the curvature of the earth rather than looking at the straight line, because straight line is not going to be the same distance as with the curvature of the earth. It's the weirdest thing. It's cool. Spherical geometry is awesome. I love it. But yes, I get what you're saying. Don't listen to what Zach just asked, okay? That's a different thing, okay? So, triangles add up to be 180, not in spherical geometry. Okay, whatever. All right, example 3, and then, is that it? Okay, last one, example 3. Woo! This is a lot. They've got a lot of stuff. They want us to find each measure. Oh my gosh. Okay, let's find x's and y's and such first. Ugh. Okay, all right, here we go. We got fractions too. That's disgusting. Okay, x's and y's. I see an x here and an x here. Okay, you cannot solve x's and y's at the same time. So I'm going to try to like incorporate the x's together. Okay, so I've got an x in this angle and I've got an x in this angle. Do we know anything about those two?
They add up to 90.
How do you know they add up to 90?
The other side's a 90.
This guy is a right triangle because this guy is 90 as well, right? Even though there's not a box there, we know that this and this add up to be 180, right? So that's got to be 90, okay? So this guy and this guy have to be 90, okay? Now, are they equal to each other? Not necessarily. That would mean they would both have to be 45. Maybe they are, but I don't know that for sure. So x plus 8, that guy, plus 2x minus 2 has to add up to be 90. Got it. Okay, let's do the math. X and x makes 3x. 8 minus 2 is 6. And then let's subtract the 6. So 3x equals, I don't know, 84. And let's divide by 3.
28.
28? Yes. Okay, x is 28. Okay, let's find what y is, and then we'll plug back in. We'll do all the things, right? Okay, so x is 28. Got it. Whoop. Okay, now I have the y's. I have a y here, and I have a y here. This angle. Do I know anything about those guys? They're both in this triangle.
They make 90. So.
Those two add up to be 90 because this is 90, right? So this guy plus this guy makes 90. Okay, I don't like 5/4. Let's go 1.25y minus 45, and then what?
Just y.
Plus another y equals 90, right?
Yeah.
Okay, so how many y's did that give you on the left side?
2.25.
2.25 y. Can I add the 45 over? What's 90 plus 45? 135. Divide that by 2.25. Y equals? I don't know. What's 135 divided by 2.25? What? I don't know. Jace, you got it? Take 135 divided by 2.25. 60? Okay. Okay, but they want not those things, not x and y. They want B, C, D. Which one is B, C, D? B, C, D is this guy right here. 2x minus 2. So I'm going to plug 28 in there. What's 2 times 28 minus 2? 2 times 28 is 56 minus 2 is 54. 54 degrees. Is that true? Okay, B. They want BAF. Which one's BAF? BAF. The disgusting one. So we got to plug 54 in there. 5/4 times 54 minus 45. What is it? Is it 30?
Yeah. Because if they have to be 90, the other one.
It is 11.
Oh, yeah. Because if this, that's a good point. She says if this is 60 and this is 90, then this one has to be 30. I don't even have to plug it into there, right? That's a good thought. I like it. 30 degrees. And that's it, right? Perfect. Okay. You're going to have a lot of little shapes like that, like putting stuff together, right? Like this. Okay. The last one is a check, and I'm not going to go through this whole one, but that is disgusting. They label this as 2x minus 1. What about this guy? He is also 2x minus 1, right? Or whatever that is after you plug stuff in, right? Okay. There you go. Okay. All right. There you go. Homework. Get to scooting.
I have a question.
Okay. Oh, by the way, like number 3, when you go to do number 3, there is technically like 5 triangles there. Do you know that? Yeah? You see the 5 triangles? There's this one, there's this one, there's this one, right? And then you've got this one. And then you've got this one. So maybe if you're struggling to find what angle 1 and angle 2 are, look at it from a different perspective. Look at a different triangle. Got it? Okay, there you go. All right. Goodbye.